This is 9.2 matrices, the first section in chapter 9 that we are covering. First of all, when we're talking with matrices, it's important to understand the dimensions of the matrix. Dimensions are rows and then columns. So anytime I ask for dimensions, it wants how many rows horizontally by how many columns vertically. So let's take a look at some different matrices and try to find the dimensions for each one of these so that we're kind of used to that before we get into operations with matrices. Now we're going to be using these same 4 matrices through all the problems we do today, so it is worth writing all of them down. If you need to hit pause to get them all written down, please do that. All right, so this first one has 2 rows horizontally and 2 columns vertically. So we would say it's a 2 by 2 matrix. The next one has 2 rows horizontally by 1, 2, 3 columns vertically. So it's a 2 by 3 matrix. You'll notice that if you multiply the dimensions, 2 times 3, that gives us 6. That tells us how many numbers are inside, and we call those numbers elements. All right, so go ahead and try on C and D to find the dimensions. Hit pause, find them, and then come back and see if you got them right. On C, we have 2 rows by 2 columns, so a 2 by 2. And on D, we have 3 rows by 2 columns, so a 3 by 2. So next, we're going to take each of those same matrices and we're going to find the element. Remember, that's just the number inside based on some notation. I just rewrote those same matrices at the top. So if you already have them written down, you don't have to write them down again, just for easier reference. We want element from matrix A, so lowercase a indicates it's from matrix A. And when you have 2, 1, that means second row, first column. So we would go to matrix A, we go to the second row, first column, and we'd get a 2. So the element or the number that's in the second row, first column is 2. So in part B, it tells us to go to matrix B, first row, second column. So we go to the first row, but the second column, and that's a -3. Okay, so go ahead and try C and D and see if you can find the elements that are supposed to be on each one of those. Hit pause and then find them and then come back and see if you got them right. C22 means second row, second column. So that would be the 2 there. And 32 would mean third row, second column, which would be the 3. Now we're going to do some operations. First, we're going to start by adding A plus C. A and C are both 2 by 2 matrices. A is a 2 by 2. We found that on the first thing we did today, and so is C. They have to have the same dimensions in order to be able to add. Okay, so we're going to take A, and I'm going to just rewrite it here so that we can see these numbers, plus C. And what we'll do is we will add corresponding elements. So we will add row 1, column 1 to row 1, column 1. So 5 plus 6 gives us 11. Then row 1, column 2 to row 1, column 2. 3 plus -3 is 0. 2 plus -5, and 8 plus 2 to give us 10. So 11, 0, -3, 10, and you'll notice that our final answer has the same dimensions as the beginning. Now when they ask us to do 2 times C minus 3 times A, we still have to have the same dimensions for C and A, which we know we have, but before we do the subtraction, we have to multiply everything in the matrix by 2 and everything in the A matrix by 3. So we'll take our C matrix, which is this one right here, and we're going to multiply everything inside of it by 2. So we have 12, -6, -10, 4. And then we're going to subtract the A matrix, but we have to multiply everything by 3 first. So 15, 9, 6, 24. Then you just subtract corresponding elements. So 12 minus 15 is -3. -6 minus 9, -15. -10 minus 6, -16. And 4 minus 24, -20. All right, then we have A plus B. Remember what I said about dimensions? A is a 2 by 2. B was a 2 by 3. Since they don't have the same dimensions, it's not possible to add them. So we just write not possible and move on. So that's how adding, subtracting, and having a scalar, that's what that number outside is called, a scalar, how all that works. But now we're going to try multiplying one matrix times another matrix. So let's start by multiplying A times C. So again, I'm going to rewrite my matrices here because we're going to use these numbers. And I'm just going to put A right, this is matrix A, and I'm going to put it right next to matrix C. In order to multiply, you have to check the dimensions. They don't have to be identical all the way across, but the middle two numbers have to be identical. So 2 and 2 have to be the same. The outside numbers don't have to be the same. They are in this case, but they don't have to be. But they tell you the dimensions of your answer. So we know that our answer is going to be a 2 by 2 matrix. Now, when we're multiplying, this gets a little tricky because you always have to take row times column. So I'm going to take the row of A times the column of B. And you can kind of either mentally or actually physically rewrite that row next to the column so they kind of line up, the 5 and the 3. Because you're going to take 5 times 6 plus 3 times -5. So 5 times 6 plus 3 times -5. That was the first row times the first column, so we put that in the first row, first column. Then you're going to take that same first row and multiply it times the second column. So 5 times -3 plus 3 times 2. That was the first row, second column, so all of that work goes in first row, second column. Now we are out of columns to multiply that first row by, so now we're going to move on to the second row. Second row times first column. So 2 times 6 plus 8 times -5. Then second row times second column, 2 times -3 plus 8 times 2. After you multiply all the rows by all the columns, then you're just going to simplify. So you're going to simplify each one of those elements. And remember, our final answer is a 2 by 2, so you should have 4 different elements in your final answer. And it should be 15, -9, -28, 10. All right, next up, we're going to try to take B times C. B has dimensions that we found earlier, 2 by 3. C has dimensions 2 by 2. Remember that I said that these middle two have to be the same? So since these are not the same, we cannot multiply. So always check your dimensions first. Check to see that those middle two are the same, because when they're not, you can't do it. All right, so let's look at 6. It looks like the same letters as number 5. They are the same letters, but now they're in a different order. Does the order matter? Well, C is a 2 by 2. B is a 2 by 3. If we put C first, look, now our middle values are the same. So we can multiply, and these outside values tell us that our answer is going to be a 2 by 3 matrix. So once we know we can multiply, we can set it up. So we're going to take our C matrix, 6, -5, -3, 2, and we're going to multiply it times our B matrix, 6, 2, -3, 0, 9, negative 6. And we're gonna do the same thing we did last time. We're gonna take the first row times the first column, and then first row times second, first row times third. Once you get through all of those, then you move on to the second row times first, second row times second, second row times third. So I want you to hit pause, give that a try, see if you can multiply all of those out. Remember, we're looking for an answer that's a 2 by 3, so you should get 6 different elements in your final answer. And after you have all of those, then hit play again and come back and see if you have the right answer. So go ahead and hit pause, give it a try. All right, you should have come up with 30, negative 18, 72, negative 26, 15, negative 57. Woo! Hopefully you got all those. All right, number 7, c squared. Well, we know that that means it's c times c. So again, checking those dimensions, 2 by 2 and a 2 by 2. So those middle ones are the same, and our answer is going to be a 2 by 2. It still works the same way with multiplication though. You don't just get to square all the numbers inside. That would be easier. Instead, you have to write out the 2 matrices, and you have to do row by column, till you get all 4 elements. So go ahead and give that a try, hit pause, and then come back and see if you got the answer correct. After you take each row times each column and then simplify, you should have 4 elements in your final answer. And they should be 51, negative 24, negative 40, and 19. And that's kind of a little intro into matrices. We did some elements, some dimensions, some adding and subtracting, and some multiplication.